Hey guys! So you might not have heard of the standard model of particle physics, have you? Well, to be honest, it's not as famous as Einstein's theory of general relativity, but in my opinion, it's just as important, if not more. So, here's the model. It kinda looks complex, doesn't it? Well, by the end of this video, I can guarantee that you will know what this is. The entire universe is made up of matter, but then what is matter made up of? That is a good question. The answer is tiny particles. Now, for example, let's take this ball. It's made out of tiny particles. But what are these tiny particles called? They are called atoms. Atoms, in Greek, literally means indivisible.
But then, atoms can be divided again into protons, neutrons, and electrons. The protons or neutrons make up the nucleus, or the center of the atom, while electrons revolve around the nucleus.
So that's it, right? Not exactly. Using modern technology, it was found that these subatomic particles inside the atom could indeed again be divided into quarks and into leptons. Let's find out more about them, shall we?
There are actually 6 quarks: up, down, charm, strange, top, and bottom. Yeah, I know, the naming is rather weird, but then when isn't it? The up and down quarks make up the protons and neutrons. So a proton is made up of 2 up quarks and 1 down quark, whereas a neutron is made up of 1 up quark and 2 down quarks. Then there are leptons. There are also 6 leptons. We have the electron, the tau, the muon, and the other 3 are neutrinos. The electron is the most famous lepton because it's the one that revolves around the nucleus.
So now we know this much of the model. But then we gotta think, why do the particles stick together? Why don't they just go flying into space? Well, that is actually a very good question. The answer is forces. In fact, physicists know of 4 different forces to date. We have gravity, electromagnetism, weak, and strong. Funnily enough, weak force isn't really the weakest of the 4. Now that title belongs to gravity.
Electromagnetism is actually a very important force, because it's actually the glue which makes the electrons stick to an atom. The strong force ties up the quarks in protons and neutrons, and also other subatomic particles as well, while the weak force is in some types of radioactivity. Gravity is a force that anchors us here on Earth. Without it, if I were to jump up, I would go flying into space.
Now, forces need to have a way of being transferred. They are transferred through particles.
For example, think of a ping pong ball. To reach my bat, it needs to be hit from the other side, and I can hit it back also. So the ping pong ball is our force, and the ping pong bat is our particle.
Now the question remains, which particles transfer which force? Electromagnetic force is transferred by the photon. Strong force is transferred by the gluon, and weak force is transferred by the W and Z bosons. But how is gravity transferred? To be honest, we don't know. But some physicists think that gravity has a particle known as a graviton. But then again, we don't know.
The last particle in the standard model is known as the Higgs boson. It's actually part of the Higgs field, which is comprised of many Higgs bosons. This Higgs field is thought to be the field which gives all particles mass, depending on the way they interact with the field. This is, however, very hard to understand. So the easiest way of saying it is, this Higgs field is responsible for all particles having their mass.
So now you know the standard model of physics. Everything you see around you, from the ground to the edges of the universe, is built up by these particles. But don't go home thinking we're all done and good. You see, the standard model isn't yet complete. Gravity isn't part of the equation, and it still leaves many questions unanswered. For example, what is dark matter? But theories like this, they help us come closer to understanding the fundamental particle reactions of nature. Soon, we may even be controlling reactions in nuclear power stations. And 20 years from now, we may even have solved the world energy crisis. Theories like this, they push our limits of technology, and they help in creating advances in the modern world. And when people look back, they will know it was all because of the standard model.